Okay, so we want to find a power series for our function, and we need our power series to be centered at the origin. So the first thing we're going to do is we're going to take our function, 3x minus 1 over x squared minus 1, and we notice that we can actually write this using partial fraction decomposition as the sum of 2 over x plus 1 plus 1 over x minus 1. Okay? So now we can even rewrite it a little bit further. So this 2 over 1 x plus 1, we can rewrite it as 2 over 1 plus x. And the 1 over x minus 1, we can rewrite it as minus 1 over 1 minus x. And what is our motivation for doing that? Our motivation is, remember that whenever you have the sum from 0 to infinity of smiley face to the end, that's equal to 1 over 1 minus smiley face. And this is whenever smiley face is in between 1 and negative 1. So that's the motivating factor for rewriting this, is because now we've got 1 over 1 minus smiley face, and so our smiley face is going to be x. And we can do something very similar with this one over here. So we can write this, bring this 2 out, so we'll have 2 times 1 over 1 minus negative x. Okay? So the first thing to note is that this first part, so 2 times 1 over 1 minus negative x, can be written as a power series. Now we've got the 2, so we'll bring the 2 over, that's our coefficient. And we'll just have negative x to the power of n. And now this is valid whenever negative x is in between 1 and negative 1. Right? Because our negative x is our smiley face in this case. And we can rewrite this a little bit more, and so we can say this is equal to 2, the sum of 2. We've got negative 1 to the n, x to the n, 0 to infinity, valid on, now what does it mean for negative x to be in between negative 1 and 1? So let's see here. So on the side, we can just write down, so let's see here. So negative 1 less than negative x less than 1. So write that as 2 different inequalities. The first one is saying that negative 1 is less than negative x, and the second inequality is saying that 1 is greater than negative x. Okay? So it's like we've got 2 restrictions on our x. So for this first one here, I can divide both sides by negative 1, and I get x is, I've got to flip that inequality. So x is less than 1, and then over here, do the same thing, and I get that x is greater than negative 1. So it turns out to be exactly the same constraint. We need x to be in between negative 1 and 1. So this is valid on x in between 1 and negative 1. Okay, so this, remember this part is the first part. The second power series is going to be relatively easy because 1 over 1 minus x, that's just the sum from 0 to infinity of x to the n, and it is valid on x in between 1 and negative 1. So to put it all together, right, so the bottom line is that, so f of x, which is equal to 3x minus 1 over x squared minus 1, is going to be equal to our first power series, which is 2 times negative 1 to the n, x to the n, 0 to infinity, minus our second power series, which is 0 to infinity, x to the n. And this is valid on negative 1, 1. Why? Because remember we take the smaller of the intervals of convergence, and so both of these intervals are the same. So we don't so we can just use negative 1 to 1 as our interval of convergence. The last part here is we need to actually figure out what is this equal to. So let me actually, okay, sorry, here we go. Copy. Let me add a page below. Paste. Okay. And so this we can rewrite as, now what I'm going to do is I'm going to combine my power series. So now I've got 2 times negative 1 to the power of n, x to the n, minus x to the n, from 0 to infinity. Now I can factor out an x to the n from both terms. So I have 2 times negative 1 to the n minus 1. Okay, and again, my new interval of convergence is negative 1 to 1. And that's our final answer.